Give me a minute. Actually, okay. So this is where we ended yesterday, right?
Yeah.
So there's another sort of an expression that you should know, that the submission of all probabilities is equals to like P1 plus P2 plus up to Pn is going to equals to 1. Okay. So this is another proposition of probability, that if you add up all of the probabilities, they'll be equals to 1. And this is for one experiment. So this is only for the outcomes of one experiment. So let's do an example for this. The example is that a biased four-sided dice is rolled. The possible scores are possible scores are 1, 2, 3, or 4. The probability of rolling 1, 3, or 4 is shown in the table below. Is shown below. Score 1, 2, 3, 4. Probability of 1 is 0.15. Probability of 2 is not given. Probability of 3 is 0.3. And probability of 4 is 0.35. You need to find this missing probability. Can you find it?
Well, I'm supposed to find the probability of 2.
Yeah.
0.2.
Yeah, that's correct. So 1.5 plus, let's say, P plus 0.3 plus 0.35 is equivalent to 1. And this gives that P is equivalent to 0.2. Okay.
Yeah.
Okay. All right. Now let's move on to the next sort of definition that you should know is mutually exclusive events. Mutually exclusive events. So mutually exclusive events mean that two or more events, let's say A and B, are said to be mutually exclusive when there are no common outcomes. So it means that A and B cannot occur simultaneously. Intersection of A union B is a null set. So from this particular uh like from this particular proposition or this particular definition, we get to the addition of the laws of probability. The first one is called the addition law of probability. And due to the nature of random experiments, most of them are mutually exclusive, which means if I am rolling a dice and if I am tossing a coin, the outcomes are both are mutually exclusive, because one is giving me a heads or a tails and the other is giving me numbers from 1 to 6. So they do not have an intersection, right? So such events are called mutually exclusive events. So this
Wait, what is mutually exclusive events again?
mutually exclusive events are that the outcomes of any two random experiments, two or more random experiments, are having no common outcomes. So if I am doing two experiments and I'm looking at the outcomes of those two experiments, and I have no outcome that is common between them, so we say that those two experiments were mutually exclusive.
Wait, so can we have an example of it?
Yeah, we can. So let's say that I'll talk about events. Okay, so I'm saying that one event is that the total of two dice rolled is 2. Okay, and then the other event I define is that the total of two dice rolled is 4. Can you tell me what is going to be the sample space for the first one?
Oh, so 1 and 1?
1 1. Yes.
Yeah,
And
that's it, yeah.
yeah. And what is going to be sample space for the second one?
3 1 1 3 2 2.
Yes.
Yeah, that's it, yeah.
3 2 2 2 2. Actually 2 2 would only be a once. Okay. So so are the outcomes of both of these overlapping? Do we have the same outcomes for both of these?
No.
So these are mutually exclusive.
Oh, okay.
Okay, does this make sense now?
Yeah.
Perfect. So when we say, okay, so let's move to the addition law of probability. Addition law of probability. Okay, so addition law of probability, we are just defining it right now for mutually exclusive events. And I think in IGCSE level, it is just for mutually exclusive events. So we say that probability of A or B is equals to probability of A plus probability of B. If it were probability of A or B or C, then it would have been A plus probability of B plus
Wait, so
probability.
what does like A or B mean though?
Okay, so A or B is just an expression that we write because we're looking at two experiments or we're looking at two events, so we write A or B. If we're looking at three events, well, it's just an expression. It just tells you that we're looking at two events.
So like, so what is the probability that something happens in A or in B? Like what can you tell me like an example of it?
Okay, so it's the same for this one. Like I can use the same example. So the first one I could call A and the second one I could call B. So we can calculate the probability of each of these, right? Because we know that since it is a dice, the total number of outcomes is 36 and the possible outcome is 1, right?
Yeah.
So 1 by 36 is the probability of A. So we say probability of A is 1 by 36. And for the second one, we have three favorable outcomes. So we say 3 over 36 is the probability, and we say that the probability of B is equals to 3 by 36. Okay. Now, when we are trying to do the addition, we just simply say that 1 by 36 plus 3 by 36 is equals to 4 by 36, which is 1 by 9. So it just means that we are trying to, so if somebody has given you two scenarios, that if I select, let's say, one stock, what is the probability that would give me a return greater than 50%? And if the same person tells you that if I invest in a different stock, what is the probability that it will give me return greater than 50? So you add them both and you say that if you sort of if you invest in both of these together, then your probability of getting a return greater than 50 is going to be this much percent, or this much. So it's basically looking at two different scenarios at a time, or three different scenarios at a time.
Oh, okay.
Does this make sense?
Yeah.
Okay. If you have any questions, you can ask me.
Okay.
Okay, so the next thing that we are going to look into is called independent events. Independent events. Okay, so two events are said to be independent if the probability of happening of A is not affected by probability of happening of B. So this just simply means that um uh, two events are sort of called independent when the probability of, let's say, probability of an event A is not affected by the probability of B. So let's say, what example can I give you for this? Mm, 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 mm. So it basically just simply means that events whose occurrence is not dependent on any other event. So if I'm saying that if we flip a coin if we flip a coin and get head as an outcome, then we flip again, but this time we get tail as an outcome. So see, the happening of one is not affecting the happening of another. It just it's just two it's just a repeated experiment. Both of them are sort of independent of each other. If I'm tossing a coin once, I'm getting heads. If I'm tossing a coin another time, there's an equally likely chance of getting a heads or a tails. So if for example if I toss a coin once, I get a heads, and when I toss the coin the next time, there is a higher chance of getting a heads than a tails, then that particular event or those events are not going to be independent events. But if I have an equal likely chance of getting a heads and a tails, then we say that the events are mutually sorry, then we say that the events are independent. Does this make sense?
Oh yeah.
Okay, perfect. All right. So from independent events, we get to the multiplication of probability. Multiplication of the law of probability. Sorry, multiplication law of probability, it's called. So in this, we say given two independent events, probability of A and B is equals to probability of A multiplied by probability of B. So another way, sort of, you how you can write this is probability of A union B is equals to probability of A into probability of B. For this one as well, you can also write probability of A intersection probability of B. Okay.
Okay.
Okay. Now I'm gonna give you a question for addition law of probability. Example is a pair of fair dice are rolled. Find the probability of getting a total of 7 or a doublet. Okay, so this is the question, that a pair of fair dice is rolled. You have to find the probability of number one, getting 7 as a total, and number two, of getting a doublet, which means that both of the dice show the same number. So can you do this?
So to get a total of 7, right? We could do the sample thing, right? What was the sample thing?
Sample. Yes, you can define a sample space.
Oh yeah, the sample space, right? The sample space are like 5, 2, 2, 5, 3, 4, 4, 3,
Wait, 5, 2,
6, 1, 1, 6,
2, 5, 3,
4,
4,
4, 3,
4, 3,
6, 1, 1, 6.
6, 1, 1, 6.
Yeah, that's it, yeah.
Yeah, that's it.
Right.
Okay, that's
Or a
for
or a double. What do you mean by that? Like 1, 1, 2, 2, 3, 3, 4, 4, 5, 6, 6, right?
yes. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Now, what is the probability? Calculate the probability of A and probability of B. What is the probability of A?
Now, how do you do this now?
By the probability formula. Remember, we did it in the last class. Number of favorable outcomes divided by total number of outcomes.
Yes, of okay.
So favorable outcomes are these outcomes that I've written, and total outcomes is simply 6 into 6.
So wait. So like, how do I do this?
Wait, let me tell you. So 1, 2, 3, 4, 5, 6. Favorable outcomes we have are 6. Total outcomes we have is, remember we did this n of f, and if two same things are happening, then we simply do the number of sort of outcomes, and we square it, and we get 36. Do you remember this?
Yeah.
Okay. So total number of outcomes is 36. To find the probability, we do number of favorable outcomes divided by number of total outcomes, and we get
So 1/6.
6. So probability of A is 1 by 6. What about probability of B?
That's but like 1/6, right? So that's 1/6 as well then.
Yeah, that's 1 out of 6.
One
Now,
out of three.
yeah. Now they're saying find the probability of getting a total of 7 or a doublet.
So 1/3, right?
Yeah. So it would be probability of A or B, and then probability of A plus probability of B. 1 by 6 plus 1 by 6. That would give you 1 by 3. Okay, now I'm gonna give you a question for multiplication that you're gonna do yourself and then share a picture on the group. Multiplication. And we're gonna do x.
What do you mean by cubical dice? So 3 dice.
Yeah, a cubical dice is okay. I can just remove cubical from it. It's just a normal dice.
Okay.
Dice and
Unbiased coin.
yes,
How can a
unbiased.
coin be unbiased? So it's gonna have heads both the sides.
No, no. So unbiased means that the coin is flat. Means that the chances of getting a head are same to the chances of getting a tails.
So it's
That,
biased then.
no, that's unbiased. Biased is when there is a higher chance of getting one outcome. So maybe there's a higher chance of getting a heads than a tails. That's called unbiased. That's called biased. Unbiased is that there is an equally likely chance of getting both the outcomes.
Also half for both, right?
Yeah, half for both.
Yeah, okay.
Okay. Okay, so the question is, a fair dice is and an unbiased coin are thrown together. Find the probability of getting an even prime number on the die and heads on the coin.
Should I say the answer in percentage?
Um, no, you should just say it in probability.
1/4.
How did you do it? I need to see the calculations.
Okay. So
Yeah.
since the dice is fair, right, and the total outcomes are 6. No, I mean like the total, yeah. So total outcomes will like there are total of 6 numbers in a dice, right?
Yeah.
So there are 6 chances that can come out, and to get a prime number, there are 3 prime numbers in the dice, right? So two,
Even.
3, and 5. Oh yeah, oh yeah, even prime number, right? 2, 3, 4. Okay, so 1 out of 6.
Yeah.
Yeah, and then 1 out of 6 and heads of the coin. It says and, right? So it's multiply
Yeah.
times by head of a coin. That's half. So 1 out of 6 times it by 1 out of 2. I get 1 out of 12.
Yeah. That's correct.
Yeah.
Yeah. So 1 by 12 is the answer. Okay. Let's do another example. Okay. A bag.
Do you have any worksheets on probability that I can
Yes.
do at home?
Yeah. So I can share them with you.
Okay.
Yeah. After
And
this.
also for other like other stuff as well, like other topics, like all the topics you have.
Yeah. So I can share probability ones with you maybe till tomorrow morning, and then the rest
Okay.
I can share by tomorrow night.
Okay, yeah, it's fine.
A bag contains 4 red and 3 white balls. 2 balls are drawn.
Wait, so 2 balls are picked up, right?
Yeah, yeah.
Okay.
2 balls are drawn from the bag. Okay. This is without replacement. Find the probability of getting both red balls.
9/49.
How?
Because there are 3 balls, right? 3 white balls, and the total balls are 7.
Yeah.
So if we pick it up once, the probability of us getting the white ball is 3/7. Yeah.
Yeah.
And then since it says without replacement, so the ball is like now in the bag now. Yeah. So the probability stays the same.
No, it says without replacement.
So you don't replace it.
We don't replace it. So the number of
So we
balls is
don't put it back.
no, we don't put it back.
Oh,
With
okay. If we don't put it back, then it's 2 out. Oh, my bad. It's
so
two,
we have to
six,
see the
one over
probability of
7.
getting red balls, not white balls.
Huh?
We have to see the probability of getting both red balls.
Yeah, yeah. So, okay, I didn't. I thought without replacement meant like the ball is now back in the bag.
No, 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 no. That is with replacement.
Okay. So, okay, yeah. So now we do. So since like the ball is now out of the bag, so there's one less ball in the bag, and
Yeah.
there's one less red ball as well. So it's gonna be 2 out of. So the probability of now us getting a white ball is 2 out of 6. And so if we multiply 3 out of 7 times 2 out of 6, I get 1 out of 7, and that's the probability.
Okay. Just that we were looking at red balls, so we need to see
Oh yeah, we are looking at red balls, yeah.
yes. So you have to see the probability, but your process was right. So I think if
Or
uh,
2 out of 7 then, yeah.
yeah, 2 out of 7. That's correct. Okay. So we're gonna do a few more questions and then we're going to end probability today. And we'll practice. So we won't practice like proper past paper questions right now. We'll first finish the other two topics as well, and then we'll start with past paper questions from hopefully next week. Okay.
Okay.
Okay. So we get 2/7 here. So another example.
Or we can just start past papers. I think I'm like confident now. So like if I don't get it, yeah, you can like just tell me that.
Okay, so then you'll have to give me like 2-3 minutes so I can get a past paper.
Yeah, okay. Because like I have an exam in like 2 weeks, so I don't think we have time for that. Like,
Sure.
or we can if we do if you want.
No, no, it's okay. I'll just give me like 2-3 minutes. Let me download a past paper.
Or I have a question that I struggle with.
I'm sure you can share that.
Oh yeah, yeah. It's wait. I just did a past paper right now, and I didn't get it. Oh yeah. It's January 2022.
Wait, let me just open your papers. Wait.
January 2022 1HR.
Okay, wait. IGCSE math past papers.
Or I can send you the link if you want.
Oh, I just opened it. No problem. So it's 2022.
Yeah, it's Jan 2022.
Jan 2022.
Question 13C.
Okay, yes, you can send me the link. I didn't find it. So your code for math is 0580.
No.
What's your code?
Wait.
Is it 0480?
Oh, I sent you the link.
Okay, let me see.
It's in the Zoom meeting.
Yeah, let me see. Wait. Oh, okay, okay. So, what is the question number?
13C.
Okay, 13. Okay, so I want you to give it another try right now on a paper and a pen. You send me it's working, and I'll see where you're making a mistake and where you're getting confused. Try to do it.
Okay.
Okay.
I just don't get part C. I got like A and B, but like for C, I just couldn't write anything because I couldn't get anything.
Okay, wait. Let me explain. Okay, so it says that Megan has a jar containing 15 containers. Wait, let me share my screen. Can you see the screen?
No.
Share it. Okay. So it says that Megan has a jar containing 15 counters. There are only blue counters, green counters, and red counters in the jar. Hector is going to take at random one of the counters from his bag of 12 counters. He'll look at the counter and put the counter bag into the bag. It means that it is with replay. Oops. Wait, give me a minute. I'll just put it in Notability so I can write on it. Okay. So from this part, we can say that it is with replacement. It says that Hector is then going to take at random a second counter from his bag. He'll look at the counter and put the counter back into the bag. Okay. So there are two people. There is Henry and there is Megan. Hector. So Megan has 15 counters and Hector has 12 counters. Hector's probability is also with replacement, and Megan's probability is also with replacement. So it says that Megan is then going to take at random one of the counters from her jar of counters. She'll look at the counter and put them back into the jar. The probability that three counters each have different color is 7 by 24. Work out how many blue counters are there in the jar. Okay. So what they've given you is uh, um, that the information that they've given you is about two people and the counters that they have, and that this is in three different colors. Okay. So what essentially you need to do is that you need to find how many blue counters there are in the jar. Okay. So probability of let's say, okay, the probability that three counters each have different color is okay. So first, we say that probability of Hector gets uh, color A is P. Probability of Hector gets color B is, let's say, S, and probability of Megan gets color C is, let's say, F. Okay. So right now I'm just explaining you this, how you're going to answer this. You have to do it yourself. You'll first give it a try and then I'll see. I'm just explaining you what approach you can take. Okay.
Okay.
All right. Now they say that the probability that counters each have a different color is 7 by 24. Now, do we think that these are independent events or mutually exclusive events? What do you think these are?
They are two different events.
They're independent events. That's right.
Yeah, yeah.
So it means that the probability of H getting A color into probability of H getting B color into probability of M getting C color is equals to 7 by 24.
Yeah.
Right?
So the probability of Hector getting color A, so for example, if we do like green, is 7 over 12, right? So
Yes.
instead of A, can we put G then? Like, yeah.
Yeah, okay. So for colors, we
So
can,
that makes sense, you know.
yeah, G and
And
of Hector
probability occurring red,
2 or red.
red, because it's a blue. There's no blue. Hector doesn't have any blue. That's why.
Yeah. And then probability of
We're getting a blue. Equal to 724. Okay. So probability of Hector getting a green is for the first time is 7 over 20. So 7 over 12, and then getting a red is 5 over 12.
7 over 12. And then you're saying that getting a red is
5 over 12
why 5 over 12?
because he has total 12,
Yeah, but why 5?
and your 7 are green. So 12 minus 7 is 5, and so 5 are red.
Oh, yeah, perfect.
Yeah. Multiply by x over 15.
X over 15.
Wait, is it 15? Yeah, it's 15, yeah?
Yeah, it is going to be. It has 15 counters. And now you
Okay.
saw that the value of X.
Oh, okay. So 5, 3, 3, then uh 3, yeah.
Mm.
Uh, 432, 7x over 432, and then 7x 432 times 32 times 7 times 3024, and then 3024 divided by answer 18.
You're getting 18. That
Yeah.
that can't be right.
Oh, yeah, that can't be right. Yeah, because there are 15 in
Yeah,
total.
their
How am I
total
getting
are,
18?
yeah. So that's not right. I think we might have done something wrong here. Yeah, let me see what we have done wrong. Just give me a minute. Okay. So it says that Megan has a jar containing 15 counters. They're only blue, green, and red count in the jar. Hector is going to take at random one counter from his bag. He'll look at the counter and put it back into the bag. Hector is then going to take um a random come a second. He'll look into
But the probability of getting a blue, wouldn't it be like green plus red and 15 minus green plus red, right? Because Megan has blue, green, and red. So if
yeah.
we add red and green and
Mhm.
15 minus red plus green,
Yeah, we can do that. 15 minus red minus green is equivalent to blue. Yeah, that is true, but we don't even know the number of green and red, do we?
no.
So we cannot use this. So there is something, I think maybe these so it's with replacement. With replacement means that every time we add a new ball, so the probability of getting the same color ball is same. So are they independent? I think they're mutually exclusive. They're not independent. Events. Yeah, I think these are not mutually exclusive events. These are not independent events because the probability of like since we are doing it with replacement, the probability is being affected, especially in the case of Hector. So I think that we'll do this with the addition law of addition. Okay, so what I'm gonna do is that you leave me with this question, and I can look into it and I can get back to you on this tomorrow in tomorrow's class.
Okay.
Okay. There's some minor mistake that we are doing. I'll figure that out and then I can tell you how to do it in the next class, like tomorrow's class, inshallah. Hopefully.
Okay.
Okay.
Mm-hmm.
So is there any other question that we can do in this paper?
There are no probability questions though.
Okay. So let me maybe find another paper. Or we just have like 10 minutes left. So instead of finding a new paper because it's going to take time to download and stuff, we can do another example that is similar to this question. The ones that I have written down from you, these are all for you. These are also taken from past papers, different past papers. So let me find one that is similar to this one.
Okay.
Okay. Okay. So we're gonna do this one. So it says that Dan either walks or cycles to school. The probability that he cycles to school is 1 by 3. Part A is write down the probability that then walks to school. B is when then cycles to school, the probability that he is late is 1 by 8. When Dan walks to school, the probability that he is late is 3 by 8. Complete the diagram. This you have to tell 1 by 8. This you have to tell. Then So this is 3 by 8. This is late, late, and then this you have to tell. Okay. So yes.
So should I
So
complete the diagram?
yeah, please do.
So walk is 2/3, not late is 7/8, not late is 5/8.
Yes, that is correct. Okay. Then part C is that then cycles to school and is late. Then is not late when he cycles to school. Okay, yes. What about these? Is actually, let's just say that is not late. Let's remove this. Are you calculating it?
I cannot see the question properly.
Oh,
Right.
no. So part A and B you've already done. You have to do part C now.
So find the probability that Dan cycles school and is late.
Yeah.
Yeah. So
Yes.
Dan cycles to school and is late.
Yeah.
1/24.
Yes.
And Dan is not late. Okay, so Dan cycles to school and is not late.
No. So it's just Dan is not late. So you have to say cycles
Oh,
to
okay.
school and not late and walk.
Cycles to school. Okay, so cycles to school is 7/8, and not cycles to school is 5/8. So do I times it? Yes.
So see, there are two scenarios. Number one is that cycles and not late, and number two is walks and not late.
Yeah.
So you first calculate the probability of cycles and not late, and you add it to walks and not late.
Oh, okay.
Yeah.
Oh, so cycles to not late is 7/8 times it by 1/3.
Yeah.
7/24, 7/24, 7/24, 7/24, 7/24, 7/24,
Yeah.
7/24, 17/24.
Yeah. That's correct.
Yeah.
Okay. So we're gonna end it here for today. And then in tomorrow's class we'll start with the past paper question, and then we'll move on to one or two more past paper questions. If you have some, you can tell me and we'll do those, and then we'll move on to the next topic that you have problem with.
Okay.
Okay.
Mhm.
All right, so I'll see you tomorrow then.
Bye.
Bye.